The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, and good evening, everyone. Welcome to the webinar today. My name is Ethan Fernandez, and I will be hosting. Besides myself, on the call, we also have Rudan Bettelheim, and he's an i.MX consumer marketer here at NXP. And we also have Drew Mosley, who is a technical solutions architect over at Mender. And today, the point of this call is Mender will be talking about their OTA software update manager, and they'll give some introductory information, discuss some key challenges, and show how to integrate their solution with NXP's i.MX 8MQuad board as an example. So just quickly, before I get into the meat of this call, there is a questions bar on the right-hand side where you can type in your questions during the presentation. We should have time at the end of the webinar to answer them. And you'll also notice in the handouts tab that I've also uploaded the presentation material there. So should you want to download it and follow along, you can. And after all this is over, we will be putting this up on DistiNet. So you can keep a lookout there for this information. But without further ado, I will hand it off to Rudan to kick it off.
Okay, thanks, Ethan. So welcome, everybody, first of all. And I would actually expect that most, if not all of you, are already very familiar with the need for OTA software updates. But to add a couple of additional points to that, specifically when you look at some of the services that are being implemented by a number of our customers, such as Amazon Alexa, Google Voice, and Apple HomeKit or AirPlay 2, these mandate the support of OTA software updates, but do not actually include the support for this in the SDK and do not prescribe exactly how it has to be done. So it's essentially left to the customer to figure out a way how to do this. OTA software updates are also very strongly recommended for all IoT applications by security experts, close to being mandated. And we've had many requests from customers for this support as well. So we've partnered with Mender to provide a full, robust, and secure solution. And one of the important things is that this is not just about having a client. In fact, that's probably one of the smallest parts. What's really needed in the full solution is the side on the server and being able to run the services there. So with Mender, as you'll find out, one of the advantages is that their client is already compatible with Yocto Linux. It's already used by some major NXP customers, but to make it even easier to use, Mender and NXP have completed the full integration for the i.MX 8M family now. So it's been tested and it works seamlessly. It's also planned that we will extend this integration support for any new i.MX 8M family parts that come out, such as the Nano that will be coming out this fall. Now, for other NXP products that run Yocto Linux, it would be possible to do this integration as well. If you see the need there, what I would recommend is that you get in touch with the relevant NXP product team. Okay, so in order to find out more, I'm going to hand over to Mender, specifically Farshad. Go ahead, Ethan, and switch.
Yes, hi, I'm Farshad from Mender, responsible for marketing. As Ethan mentioned, we'll have Drew go over the presentation and what are the challenges in OTA software and how we've done integrating Mender with NXP. Drew, please take it away.
Very good. Thank you so much for the introductions, and for all attendees, definitely thank you for taking the time. Hopefully we'll answer all your questions and give you an idea of what Mender's all about. So just at the very highest level, Mender is an over-the-air software update manager for embedded and IoT devices. Of course, that's what the slide says. You can all read that. And we'll get into a lot more details as we go on, but the couple key points here, it's over the air. There are a number of solutions that allow you to do updates, but you know, they might not have the over-the-air capabilities, or they might not be as robust. So those were really our primary goals, is making sure that this update capability that we added was as robust as it can be made for unattended devices when they are deployed remotely. So briefly, a little bit about us. Our company is called Northern Tech. We have a development center in Oslo, Norway. We have an office in San Francisco, and then a few folks like Farshad and myself are remote employees working from our homes in various locations. The company itself has been around since 2008. Mender as a project started, I want to say, about 4 years ago now. So along the bottom, you see some logos here of folks that are customers and partners that we work with, and I'm sure you're familiar with many of those. And our overall company goal is security of connected devices. So security and robustness, and I will probably say those words a couple hundred times during this presentation, but those are our primary our prime directive, as it were. Just some testimonials here. I won't read through this. You're going to get the slides. I believe there's a link actually in the GoToWebinar control panel where you can download the slides directly. Just some customer testimonials here. We do have some customer case studies on our website if you want a little bit more detail than that. Speaking of the cloud partners, I will briefly mention this. We have worked with both Google and Microsoft to enable integration with their IoT platforms. And basically what this means is that the devices authenticate using the same set of credentials between the Mender server backend and the Google or Microsoft backend to make sure that a single authentication step is all that's necessary. There is a link down at the bottom of this slide. It's a link of our product manager and CTO on the Microsoft IoT show, giving a demonstration of Mender. If you want to watch that, we certainly encourage that. So, as Rudan said, probably everybody on this call is at least understands the idea that updates are necessary. But just to give a little bit of statistics here to kind of motivate this a bit, you see the statistic here about 1 to 25 bugs in every 1,000 lines of code. That was from Code Complete by Steve McConnell many years ago. It was a broad industry statistic covering a lot of different industries. So obviously, it's going to vary a bit from industry to industry, but the point is still valid, that there will be bugs. Anytime you ship code, there will be bugs. Fortunately, not all bugs become vulnerabilities, but the more bugs that are out there, the more likelihood that there's something nasty waiting to be exploited by nefarious folks. Additionally, having the ability to update things in the field does give you the ability to roll out new features. To roll out new features without necessarily having to do recalls and expensive things like that. On the right side of this slide, you also see just some statistics related to the Linux kernel, related to bugs that have been discovered and how long they were actively in the kernel throughout the release cycles. So, you know, and that's just at the kernel. Obviously, any of these systems has quite a bit of code involved that could potentially turn into exploits. So the ability to update these devices in the field obviously is quite critical. Malware, I'm sure you've all seen the headlines, things like Mirai Brickerbot. There was just recently, I don't remember the name, but some new or variants of these kind of things that are out there. They started pretty simple, mostly taking advantage of just known credentials that were provided as defaults that users of many of these devices didn't update, but they are getting more sophisticated over time. You know, we expect these kind of reports to continue, and hopefully, as an industry, we'll be able to react to them appropriately. And robustness and security, just in general, there was an incident several years ago with a smart lock that tried to do an OTA update, and the wrong image was delivered, and that ended up locking folks out. So there's a lot of things that need to be considered when you are implementing your OTA update system. We'll get into, we've got some slides showing some of the higher level items later on. Tesla is known for having a fairly good update mechanism, and for a while they didn't have proper cryptographic validation and signing, and there were some theoretical exploits that were discovered related to that. So there's a lot of things to consider here. And our biggest competitor is you know, a homegrown mechanism. A lot of the customers we talk to, they don't think about OTA until fairly late in the process, or they just think, oh, it's fairly easy. I'll just send over a tarball. I'll extract the files, and we'll be good to go. And you know, at the very most superficial level, yeah, that's all that an update needs to be. However, there's a lot of details that get glossed over there. In most cases, those that we spoke with that implemented their own OTA mechanism found that it took quite a bit longer than expected and cost quite a bit more than originally anticipated. Additionally, you know, typically these developers, this is not their core competency. They're not. This is just something they throw together at the last minute. They're not thinking about all the ins and outs of this kind of an update mechanism. So it takes away their focus from what their core competency is. And just another thing, complexity, you know, in terms of time to market, I can't tell you how many folks we talk to that they come to us and they say, yeah, we want to go live next week. Can you help us add an OTA update because our development of that feature failed? So there's a lot of risk in doing this yourself when there is a solution like Mender that's a ready to go out of the box solution. So the high-level requirements that any OTA system should have. Obviously, you want to be able to update all the components in the system: the kernel, the device tree, all the root file system files. Ideally, the bootloader. Although without hardware support for redundancy at the bootloader level, it's kind of hard to be done completely robustly. In most cases, if you are updating the bootloader on an unattended device, there's a window of time during which the device could be bricked. So that's something to carefully consider if you really need bootloader update capability. The ultimate goal, certainly of Mender, is to never leave a device unusable. And that's what we mean when we talk about robustness. You know, we use fully redundant root file systems in most cases to give us that fail-safe capability and rollback capability. It's extremely important since you know, these devices, there's no telling where they're going to be deployed. You want to be able to ensure you can deploy an update, and if there is an issue, that the system will automatically roll back and into a known good configuration. Another important component is atomicity in your updates. You want to make sure that no component in the system other than the update client itself is ever aware of a partial install. These installs may fail for a number of reasons due to, you know, dodgy power or dodgy networking, or just general being deployed in uncontrolled environments. So from the OTA requirements perspective, you definitely want the ability to ensure that you get completely atomic updates. Everything's either completely installed or it's not installed at all. Also, you want some kind of integrity checks, checksums for handling just bad data transmissions. You want signatures, cryptographic validation to protect against man-in-the-middle type attacks. Compatibility checks. This is, as I mentioned with the smart locks a couple slides ago, it was missing a compatibility check, and an ARM v5 image got installed on an ARM v6 device or something like that. So you want to make sure that the image that's being installed is what is actually expected for the given device. And then some means of storing data persistently across updates. You know, things like Wi-Fi credentials or configuration or calibration information, all of those kinds of things. You don't want to overwrite those on every update. So there needs to be some means for moving those pieces of information into data storage. The link at the bottom here is a white paper that we've written up that goes into a lot of detail. I think it's a very useful document, so I would encourage you, if you have any questions that are not answered by this call, or you just want a little bit more detail, I would encourage you to take a look at that white paper. So why Mender specifically for OTA updates? You know, at the non-functional level here, we're fully API based. Everything on the server side, everything you see in the Mender Web UI is accessible over HTTP REST API. So if there's some functionality that you would like to add that is not available through the Web UI, it is easily scriptable using that REST API. We're fully open source, MIT based, Apache 2 license, meaning, you know, no vendor lock-in. Everything we distribute is on our GitHub page. You can go download the sources. We also distribute the back end as Docker, pre-built Docker containers in the Docker Hub. So all of that is there if you want to avoid vendor lock-in. Security and robustness, I'll mention those two terms again. That's our bread and butter here. We focus every change we make. You know, that's always in our mind to make sure that we're not reducing either of those. We're a fully end-to-end system. We've got both the client and the back end. There are a number of other client solutions out there that may integrate with you know, third-party servers. The integration does work, but it's maybe not as easy as a full end-to-end solution. And we think that the combination of having the server and backend developed as a single whole results in an overall better user experience. We do have a fairly active community site that are on the Mender Hub. And this is where people can post their use cases and ask questions and get feedback from other users of Mender. We get a lot of good ideas from our users on this site. There are a number of integrations of Mender onto different platforms, different Linux-based operating systems and that kind of thing that maybe we don't directly support, but that folks have been able to get up and running on, you know, hardware that they have and that kind of thing. So it's a good place to go to get general information. If you have any questions about Mender and, you know, how you might want to do some specific thing with it, that's usually the best place to start, because in a lot of cases somebody else has had a similar issue and may be able to point you in the right direction. You see some statistics here about our test coverage. On every pull request, we have automatic testing that runs, and we're consistently right around the 80% range of test coverage. And the documentation that we provide, that's one of the things that a lot of people are very pleased with, is you know, the quality of our documentation. We do try to keep that up to date and extremely current. And finally, we have a number of delivery options. I think we got a little bit more detail on that, so I'll kind of gloss over that for the time being. So I mentioned Mender Hub. So this is kind of what the website looks like. It's just a kind of a community forum site where you can go find integrations. This is actually where the NXP board integrations are stored, and the details and instructions are on this site. There are other things here such as build root. I've seen some discussion of OpenWRT on various various platforms and that kind of thing. So there's a lot of good information there. Definitely encourage you to take a look at that to try to get a sense for what all information is available. So getting in a little bit into the more technical details, when we're talking about system updates, what we're talking about here is a full root file system update. So the primary update mechanism within Mender requires redundant root file systems, and this is of course how we get the security, how we get the robustness and the ability to roll back. So we have fully redundant root file systems with a persistent data partition. This allows us to conditionally boot into a new update, do all our post-install checks, make sure everything looks good before we commit that update as completed. If during those post-install checks anything fails that Mender can detect, it will automatically reboot and will roll back into the previous known good configuration. If something happens, say for instance a kernel crash, where the Mender client is no longer able to run, as long as we have not done that explicit commit that comes at the very end, then on the next reboot, the system will detect that as well and roll back. So standard Linux techniques using watchdog timers and that kind of thing can detect these kind of situations, which are obviously out of the control of the Mender client running in the user space. We do use industry best practices for TLS. All transport between the client and server is TLS. We have cryptographic signatures that we can apply to the images to make sure that the images that you're being installed are the ones that are expected. And even if something were to happen on your server and it were to get taken over by a bad actor, they wouldn't be able to inject bad images into the Mender workflow. In addition to the full root file system updates, we also support application updates in a more generic fashion. Depending on how these are implemented, this may reduce your robustness a little bit. You can do package-based updates using things like RPM or deb. You can do container-based updates. You can do just individual files and directory updates. And then there's a few other things that we could potentially support with this mechanism, such as proxy deployments, which is basically the Linux system running the Mender client, proxying updates to peripherally attached devices. These might be microcontrollers running on RTOS. They might be other sensors and things that are connected over I2C or something that might have a firmware load that needs to get updated. In this case, the expectation is that the Linux client or the Linux device itself has some mechanism to update the firmware on these devices, and the Mender client just proxies those updates over to the devices. Anytime you're looking at things like this, like if you're looking at RPMs or deb packages and that kind of thing, under the hood, Mender is still using the RPM utilities and the dpackage utilities. So anytime you want to do rollback, then you have to somehow maintain the old versions of the packages or containers or files to make sure you can roll back. Since we're not using, in this case, obviously the redundant root file system, we don't have an implicit rollback mechanism, although there are enhancements that can be done there as well. So if you do have the need for a fully robust package or file-based update, it is possible to use that inactive partition, but that's going to slow things down, because essentially you're going to, at that point, back up your active partition to the inactive partition and then install the new packages, and if there's issues with it, then simply reboot into the backed up copy. So most folks choose to when they're doing a package-based update, they choose to live with that limitation. But if you are choosing to install a large number of, for instance, RPM packages, then that may be something you want to consider, since the RPM package manager and the APT package manager has some issues when it comes to atomicity at that point. Just a couple other things to mention about Mender. Obviously, we use compression to save bandwidth. That's pretty industry standard. The integration with Yocto is fairly straightforward. We have a meta-Mender layer, which makes it fairly easy to plug into any new configurations. We try to make it as automatic as possible, although the bootloader integration sometimes adds a little bit of complexity, and depending on exactly how your platform code is implemented in U-Boot, that's where some of the issues show up. We do support raw flash as well as SD, MMC, and eMMC. On the client side, we have a scripting interface that allows you to plug in custom scripts for your particular application at any of the state changes within the Mender workflow. So, for instance, if the typical pop-up that comes up and on your mobile phone that says that there's an update and I need to reboot, is now a good time, that could be implemented with a pre-reboot plugin. So you would implement just a script that shows that user interface element to the end user, and then based on their input, the plugin script that you implement can then either allow or delay the actual reboot process. If that scripting interface doesn't give you enough flexibility, you can also, as I mentioned earlier, you can actually code custom scripts that use the backend API to do things that you may want to do. So, for instance, if you wanted to do some fancy deployments to certain devices only at certain times of day and certain times of the year, or whatever your actual use case may be, you can actually code that up, hit the API to enumerate the list of devices, figure out which devices are appropriate, and create custom deployments for those particular devices. And finally, the Mender client is designed to have fairly low system overhead at runtime. Anytime there's new updates and that kind of thing going on, typically the rest of the system doesn't even need to know this is happening. It all happens in the background. We require very little in terms of storage space or CPU cycles. The new update, when you are installing a full root file system update, the new block image is streamed directly to the passive partition so that it doesn't require writing a large file to your currently active root file system. And the application can continue without being interrupted. So I mentioned briefly that we have a cryptographic signature mechanism built in. So essentially, this is using just standard RSA or elliptic curve DSA, and the key pair, the private signing key never leaves the ideally air-gapped signing system. Exactly how that is implemented is really up to the end user. You can't actually integrate that into the actual build portion of your system through your CI system or whatever, but those systems generally aren't quite locked down as an air-gapped system would be. So if you want to do the signing after your CI system in a fully air-gapped way, that is something we support as well. This obviously requires that the verification key is deployed onto the target system at initial device provisioning time, so that any over-the-air updates that come in, the signature that is on those images can be verified with that public verification key. And just a couple things that are on our roadmap. Delta updates. So hopefully in the next couple of months we'll be releasing a version of Delta updates. And basically what this is if we assume read-only on the target and we know what image is installed on the target, we can actually calculate the diff between the old and the new image and only deliver the updated bytes. And so this obviously reduces the file size, so that reduces both the time of the download as well as the cost in the case that you're on a low bandwidth or expensive connection like a 3G connection. We will be beefing up our campaign management features. We have a generic grouping mechanism today, but the idea of our campaign management will be to allow you to in a controlled fashion, roll out and update across a large device fleet. Very similar to how mobile phones handle it today. New updates come out and they'll roll out to a small percentage, get some telemetry back, start to get some reports. If the image looks good, then they can roll it out to a larger group. If there are issues, obviously they can cancel the deployment at that point, address the issues, and move forward. We are also going to be adding a multi-tenancy feature. This basically allows folks that are doing on-premise installations of Mender to have individual customers, individual users of that system without them seeing each other's data. It's very similar to how we do things on our hosted Mender today, where we obviously have multiple tenants, and this will be something that's rolling out to our enterprise stuff fairly soon. So to look at the entire product value chain here, OTA updates have different value for different folks. Obviously on the supplier side, it's nice to have an off-the-shelf solution that they can just sell. Customers are asking for some capability to do it, so having it built in and ready to go is good value for them. For device manufacturers, obviously, if you don't have to take the time to actually implement something yourself, that's good for your time to market. Makes things move more smoothly. Product managers like a system like this because they can deploy new features, they can deploy updates rapidly without a whole lot of interference and developer activity. Developers like it because it allows them to continue working on the things that make their product unique. It does give them in the development system, it gives them the capability to actually deploy updates quickly on their test systems for testing new features and that kind of thing, and then makes it fairly easy to get their features rolled out to the end users of their devices as well. And finally, consumers, obviously they buy these devices. They want them to be secure whether they know it or not. If we can keep their devices up and running longer, obviously that results in more satisfied consumers. So these are some of the main components of any update workflow. So the maroon, the items are considered must-have. The blue items are not quite must-have, although I would say in any real system, a lot of them are required. Some means to detect the update. In our case, Mender has a polling mechanism where the client reaches out over a TLS endpoint just to ask the server if something is available. Compatibility check, we mentioned that. Download over a secure channel, again, TLS comes into play here. Integrity and authentication, they're split out here, but depending on how it's implemented, they may actually be the same thing. Integrity really is to detect against inadvertent data flips or whatever, just corrupted data in the transfer, whereas authentication and signatures is intended to protect against bad actors. And then things like decrypting, extracting, those are dependent on the exact format of the payload and that kind of thing. So pre and post install actions, these are very nice to have. Things that I mentioned earlier related to customizing the Mender workflow for your environment. Pre-install actions might be things like database migration. Post-install actions might be things like verifying new drivers are working, and that kind of thing. And then restarting is obviously dependent on the payload. If it's a full system image, you generally want to restart to get the new kernel. If it's a package-based update or a container, you might just be able to restart certain services. And then post-install sanity checks. From the Mender perspective, we verify that the Mender client obviously is up and running and is able to check in with the server to make sure that even if there is an issue, we have the ability, we still maintain the ability to install another update later on. And finally, probably, from a robustness and security perspective, probably the most important thing here is really that failure recovery and rollback, depending on what the particular failure mechanism is. So I talked about this quite a bit. This just kind of shows a little bit more in-depth picture about what does the AB image update look like. We have the two root file system partitions as well as the persistent data partition. Depending on the system architecture, the bootloader may be a partition, it may be a separate SPI flash device, whatever, but there's at least a logical partition for that. So at runtime, we're running in the active partition. When it's time to install a full system update, we populate that inactive partition, and if there's issues with it, we still have the previous partition available for that rollback. And update modules, that's the functionality that implements the custom update types, such as package-based updates and container-based updates and that kind of thing. So the Mender client, the AB image, full image updates, that's kind of an integral part of the client, whereas update modules breaks out the fundamental update operations into a plugin that can be implemented for either generic out-of-the-box things such as just standard RPM or dev package updates, or you can implement very custom things such as the proxying firmware for a maybe an asymmetric multiprocessing system or something along those lines. And so just to go in a little detail on the server, this is kind of an eye chart here. There's a lot of detail here. The box on the right is kind of a block diagram of the server, but the couple key takeaways here. The only connections needed are to port 443, which is TLS, and port 9000, which is that's how our storage proxy is implemented. That can also be redirected to something like Amazon S3, where in that case you would only have the control traffic going to the Mender server, and the actual artifact downloads would be coming from something like S3, which obviously has quite a bit of load balancing and that kind of thing to make things go more smoothly. But the final key point I want to leave you with on this slide, just about all the microservices are stateless, which allows us to horizontally scale them as need be for a given device fleet and workflow. The state, once it gets written out to the database, obviously, if that becomes the bottleneck, then database scaling techniques are fairly well known and understood, and MongoDB does have quite a bit of support for that. So this system is designed with scaling in mind and should be able to grow with the device fleets as appropriate. And just briefly, if you go to our docs site, we do have a demo environment there under the Getting Started section where you can actually spin up a test server on whatever system you may have. Any system that can run Docker is able to spin this up. It's a Docker Compose based multi-container bring up script. You just check it out of GitHub and spin it up. We provide demo images for an emulated platform that runs as part of that Docker Compose environment, as well as a Raspberry Pi 3 and a BeagleBone Black. The functionality in there is really designed specifically for testing the Mender server and the Mender workflow. So you're not going to be able to use these images to do much other than get a feel for how Mender works, but it is a quick way to get up and running. And you can do a very similar setup with the NXP boards, which is in the Mender Hub. There's instructions on how to do that as well. So delivery options for our back end, we have basically three ways to do it. We have our on-prem, which is you go grab the Docker images directly from Docker Hub, deploy it on whatever hardware you may have available, and manage that all yourself. We have our hosted Mender service. So, a lot of the embedded developers, they don't really have expertise in server scaling and uptime and concerns like that. So they want to continue doing the embedded development, but they want to outsource the scalability and uptime concerns to us. And then we also have our Mender Enterprise, which is obviously intended for larger enterprises. It's basically the same thing as hosted Mender, only in an on-premise format. So that's where the multi-tenancy is going to come in. That's where the Delta Updates is going to come in, and that kind of thing. This does come with SLA-based support contracts and that kind of thing. So device integration, I think we touched on a lot of this already. But the partitioning, modifying a Yocto configuration, or really any Linux configuration to support Mender on the client, the actual client application is fairly straightforward. That's just another client app running as a system service. The most invasive portion is really where you're adding the multiple partitions. So it's definitely something you want to consider early in the design phase, and not really wait until you get close to release. And I mentioned our meta layer, but you see the link here. This is when you're building with Yocto, you'd add this to your Yocto configuration, and then there's a couple extra variables that need to be configured in your local.conf or in your custom BB class files and that kind of thing. And then you should, that gives you the ability to build. You see the output here. There's really two kinds of files that are output. There's one that's the SD image file. That's the multiple partition binary that gets initially provisioned to whatever storage media is appropriate for your device, whether that's SD card or eMMC or raw flash. And then there's the .mender file, which is the actual OTA artifact that gets uploaded to the Mender server and then deployed over the air. I'll briefly mention Mender Convert. This is a utility for using non-Yocto type systems. It's basically a post-processing step if you have, say, a Golden Master image built with build root or Debian or Ubuntu or whatever. This tool set is a way to actually add the Mender client and generate the multiple partition and that kind of thing. Currently, it only supports Raspbian on the Raspberry Pi and Debian on the BeagleBone Black. We are looking at ways to enhance this to make it a little bit more expandable in the future. If you have needs for something like this, please feel free to reach out, and that will certainly help us to prioritize updates to the Mender Convert utility as we move forward. Quality assurance, I already mentioned this. You see the link over here, or the image over here on the right. This is actually what happens on any GitHub pull request. We have a number of checks tests that get run on any pull request, and code coverage gets updated as well. So we do a fairly good job of keeping this up to date, and like I say, it happens on every pull request, so it's continuous. So specifically with the NXP integration, everything that we've done is based on the NXP Yocto board support package. There's basically one command line parameter change from your normal Yocto build setup, I believe. The NXP BSP functionality is not touched. It's just we just add the Mender functionality into it. At this point, we only support the two i.MX 8 boards that you see listed here. But given the maturity of the NXP board support package, it's fairly easy to add more. Again, if you have specific needs on specific boards, please feel free to reach out and help us prioritize that. The links here go back to the Mender Hub, and that's where you really want to use to get started. I would encourage you just to pull these slides up and click through the links so you can see exactly how to integrate this into your builds. And the bottom couple of lines here show really the only difference that needs to be done. Instead of calling FSL setup release, you just call FSL setup Mender, which will then call FSL setup release on your behalf. If you've got a Yocto build and you're familiar with how to do it with the standard FSL setup release.sh, then getting a Mender integrated version of this up and running is essentially trivial. And now I'll go ahead and jump over to a demo. I've got one of my colleagues has an i.MX 8MQuad board sitting on his desk in Sweden. I'm in Florida. So let me switch over to that real quick. So at this point, you're actually seeing the terminal on that device. I'm just showing the logs from Mender. It's set up with a fairly high polling interval, or fairly low polling interval now, just so this demo runs nice and quick. So you should see this coming through. And if we jump over to the actual hosted Mender interface here, so this is our hosted Mender interface. This is the main dashboard where you see kind of everything at a glance. And then in this case, you see devices. I've already accepted the device in the fleet, so if I click through, you see the identity out of the box. We use the MAC address to identify the device. And then in inventory is just a set of key value pairs. Both the identity and inventory can be expanded by fairly simple scripting running on the target for serial numbers or whatever might be useful for your particular application. In the releases tab, obviously these are things that you can install. You can look at the artifact contents. In this case, it's an actual root file system image, so that's that full dual AB type update that needs to be installed. We've got both release 1 and release 2. If we look back over at our devices tab, we're on release 1 now, so I'll go ahead and I'll create a deployment moving this device to release 2. And this should just take a minute or two, and our device will have rebooted. Let me bring my, so now you should be able to see kind of both the console window and the Mender dashboard here. So at the moment, after the device checks in with the Mender server, this deployment we see here will move from pending to in progress, and then actually we see over here in the Mender logs that it's actually already started the download, and it's deploying to that inactive partition. So if we come back over to the Mender deployment window, we can kind of monitor things here. If I remember right, it takes about a minute and a half or so for this to run. This should complete, and we'll have a board that has been deployed, has been updated completely unattended. So we see the device rebooting now. It comes up, runs all its post-install checks. Once that all completes, the Mender client will reach out to the server. It will indicate that it was a successful update, and it will commit that update, and then our device will be officially running release 2. So now we come back over here, and in just a second, this deployment will switch from in progress to completed. There we go. So that's basically what Mender looks like. Let's jump back over here. I know we're coming up on question time. We got just a couple more things I wanted to make sure to present here. So just a bit of detail about what services we bring to the table. We do have a professional services team. If you want specific integrations of the Mender client, that's one thing we do quite a bit of. Including partition layouts, how to do the backend setup, how to integrate with your CI/CD pipeline, or custom update scripts or custom update modules for your proxy update needs. We do also just have general embedded Linux and Yocto consulting. We have a couple resources with quite a bit of experience in those areas. And if you need custom recipes or custom DSPs or whatever, we can certainly help you with that. And just a couple links here. Encourage you to reach out to us. contact@mender.io is it's an email alias that will go to myself and Farshad and a number of other folks. The links along the left side of the screen are definitely the best places to get started. We've got the Mender Hub, the Getting Started Guide, and that kind of thing. And if we reply, as I mentioned at the very beginning, Northern.tech is our actual company. So if you see an email from Northern.tech, that's us, even though you may have originally mailed Mender.io. So with that, I think we've got about 10 minutes for some questions.
Yes, thank you, Drew. We do have a few questions, so I'll go ahead and start asking. So the first one is, so it looks like, I think this was just a clarification question, but it looks like this is more like a service offered as customization at the U-boot or other bootloader level for signature verification, flash map definition for ping pong images, etc. Is that correct?
Well, those are certainly things that we can help with. Mender, that's not all that Mender requires. Things like signature verification, that's actually done by the client in the Linux runtime. So if the signature verification fails, the image won't even be installed, and that all happens, in the actual Linux space rather than at the bootloader space. The logic in the bootloader is really strictly focused on selecting the active or the passive partition. So the Mender client running in Linux actually writes environment variables for the bootloader to direct the bootloader in how to do that. So we try to avoid adding any extra complexity to the bootloader and try to do as much as possible in the Linux space. Not sure if I answered that question, but if there's something else specific that you wanted, whoever asked that, please feel free to post another question.
All right, so the next one is, excuse me. If the Mender client is hosted by Linux, how can you guarantee that both file systems don't get compromised at any time? For instance, a misbehaving update could be placed in the passive and active partition. How do you isolate it from Linux?
Well, the Mender client, we're obviously not, Mender itself is not a exhaustive security solution. So, if you have poorly behaving code, or if you have, if your device gets compromised, obviously those device nodes are still accessible. From Mender's perspective itself, though, we will never write to the active partition with a full system update. So the new update comes in and it gets streamed directly to the passive partition. And in a lot of cases, developers are actually able to make their systems read only, which is another layer of protection. Obviously, it doesn't protect against all possible scenarios, but it certainly can help protect against inadvertent corruption of the active file system, which sounds like what that question was based on. And then other than that, it's really just a question of us doing our job to make sure that the Mender client is well behaved and does what it's expected to do.
All right. And Drew, if the signature verification is part of the Linux itself, how is the signature verification done with the Linux kernel upgrade?
Well, so signature verification here is different from secure boot, and so essentially the signature verification is strictly about making sure that the actual over-the-air artifact is properly signed. So we will download that artifact and we will verify that signature before allowing that artifact to boot. So the kernel is actually part of the root file system. So if you're doing an over-the-air update to update the kernel, then you're simply providing the kernel as a binary in the new root file system, and the bootloader is configured to actually pull the kernel directly out of the root file system. So it's certainly not a substitute for implementing secure boot to make sure to add the add that level of protection, but that's not what the certificate signature verification in Mender is intended for. It's really that's really intended to protect against man-in-the-middle attacks on the server infrastructure itself.
Okay, so the assumption is that Linux is part of the secure boot, which does not need to be the case. The bootloader alone can be part of the secure boot.
Right. A secure boot is orthogonal to Mender. That can be implemented, but it's not something that Mender is directly involved with. It's basically just a completely separate feature that could be implemented in your Linux runtime.
Okay. All right. Thanks, Drew. So we do have a few minutes, so I can leave it open if more questions come in. But in the meantime, there were some questions that Farshad was able to answer during while you were speaking. So we can probably just, and for the sake of the recording, we can also ask them again. And maybe, Drew, you can give your input as well.
Sure.
So one of them was, Android offers OTA features by default. Is there anything that Mender offers that is superior to the default offering in AOSP?
Well, my understanding is that what they offer is pretty much functionally equivalent in terms of the redundant root file system, the dual AB support. I know, of course, that requires that you're running Android. So if you have a system that's not Android, that doesn't do you any good. So that's where you would really start looking at Mender. We have talked to some folks about implementing Mender for Android systems. If they had a heterogeneous device fleet of some Android and some non-Android, but they wanted to use the same workflow. So from a redundant root file system perspective, I think functionally they're equivalent. I can't comment on the specific implementation details because I honestly don't know the details of the Android system. But our update module framework gives us a lot of flexibility that may or may not be available in Android. Again, it's not something I'm familiar enough with to say.
Okay. And I think you had this on your key contact slide, but maybe we can just reiterate, who do we contact for Mender Ops?
Well, contact@mender.io is a good general purpose email address. If you are looking for ops as far as our hosted solution, support at hosted.mender.io. But if you do, they essentially go to the same group of people. I think the hosted one may go to a few more folks, but if something comes into contact that's not the right place, we'll certainly make sure it gets to the right place.
Awesome. All right, so I'll ask another one, and because right now we don't have any more, but that might take us to the end. So just quickly, is there a feature offered to update images on the product using a USB disk, if present, as a recovery?
Yes.
Connectivity is lost for some reason? Yes,
and thank you for mentioning that, because that was something we did not mention. We do support Mender in a standalone mode, is what we call it. And in fact, basically at that point, you're just using the Mender client as a standard Linux application. You just invoke it from a script or whatever. It takes a command line parameter of either a file name or a URL to where the Mender artifact is stored, and it installs it just as if it were done by the Mender backend. So the whole magic USB key solution. We do have some folks that they have completely disconnected devices. They like the idea of the robustness and rollback and atomicity and all that, but they don't necessarily have the capability in their systems to connect to to have a live internet connection to connect their device to the back end. So using Mender in the standalone mode is certainly a way to do that.
Awesome. Well, that's the last of the question, and we do have 2 minutes left till the end of the hour. So I think we will close out this webinar. thank you, Drew, for presenting. Thank you, Farshad, for being on the call with us, and thank you, Rudan. Again, like I said, this recording and this presentation will be up on DistiNet, though that does take a couple days. So if you do want the material more immediately, I will have that ready today. So you can email me directly if you want that stuff today instead of having to wait. But again, thanks everyone for joining, and we will see you later.
Thank you.
Thank you.
Thanks as well, and bye.
Bye-bye.